Okay, this lecture will be on Schmitt trigger. Here you can see that this is an inverting comparator with a positive feedback. What is a Schmitt trigger? Schmitt trigger is nothing else but it is a comparator with a positive feedback. Why I am calling it as an inverting comparator? Why? Because I have connected my input voltage to the inverting terminal. Since it is connected to the inverting terminal, I can call this circuit as an inverting comparator with a positive feedback. It's an inverting comparator with a positive feedback. And this circuit, what does this circuit does? This circuit will convert an irregular shaped waveforms. This circuit will convert any kind of irregular shaped waveforms into a square wave or pulse. This circuit, what is the application of Schmitt trigger? It is a circuit which will be converting any kind of irregular waveforms into a square wave. It means if you are giving your input signal, if you're giving your input signal as a sinusoidal waveform, that sinusoidal waveform can also be converted into square wave. If you are giving a triangular waveform, that waveform also can be converted into square wave. Or else if you are giving a square wave, it also been converted into the square wave. So now Schmitt trigger is nothing else but it is a comparator with a positive feedback. What is a positive feedback? You can see now. Earlier in our circuits, the feedback was connected between the negative terminal and the output. But now here, your feedback resistor is connected between positive terminal and output. So that's why this is called as a positive feedback inverting comparator. Your Schmitt trigger is a positive feedback inverting comparator which can change any kind of irregular shaped input signal into a square wave or pulse signal. So that's why we can call this circuit as a Schmitt trigger, or else it is also has got another name. The name of that circuit is called as squaring circuit. It is also called as another name. The name of the circuit is what? Squaring circuit. So now let us enter into this circuit. What does this Schmitt trigger does? The input voltage which you see here, the input voltage Vin is triggered. The input voltage Vin is triggered. What is meaning of triggered? The input voltage will change the output voltage. Whatever the signal you give here, that input voltage will change the output voltage. So that's called as triggering. The input voltage Vin triggers the output voltage Vout every time. Every time this input voltage exceeds some particular voltage level. That is about the Schmitt trigger. In the Schmitt trigger, what happens? You give some input voltage over here. This input voltage, whenever this input voltage exceeds some particular level of input voltage, then you will be getting some output voltage. That is called as a triggering of Schmitt trigger. In the Schmitt trigger, the input voltage will trigger the output. Trigger the output means what? It will change the output whenever that input voltage exceeds a voltage level. That voltage levels are called as the upper threshold voltage or lower threshold voltage. Means there is some threshold voltages are there. There are some threshold voltages. Whenever that voltage, input voltage exceeds some level, then you will be getting some change in the output. So see now, in the graph you can see, this is my sinusoidal waveform I have given here. Whenever this input voltage, now this is my VUT. I hope you can see it clearly. VUT is the upper threshold voltage. Whenever this is VLT is a lower threshold voltage. This is VLT. This is a VUT. Whenever the input voltage exceeds this VUT, what is my VUT? It's a 25 millivolt. Whenever my input voltage exceeds this VUT, that's upper threshold voltage, I'll be getting my output. There is a change in the output. That's what I told you. The input Vin will trigger the output. Means what? The input will change the output whenever the input value changes to some particular voltage level. What is a particular voltage level here in my graph? The particular voltage level is a 25 millivolt. Whenever the input voltage exceeds this 25 millivolt, there will be change in the output. Means the output will be changing from high to low or low to high. So see now. Here it is exceeding 25 millivolts, so that's why I'm getting this value of change in the output square wave. Then again you can see here, it will sustain until the next threshold voltage. It will be sustaining until the next threshold voltage. What is the next threshold voltage? It's a -1, minus 25 millivolt. What is a minus 25 millivolt? It is called as a lower threshold voltage. The positive 25 millivolt is called as upper threshold voltage, and this one is called as a minus threshold voltage. That is a lower threshold voltage. Now you can see, whenever the input voltage exceeds this one, it is going beyond this minus 25, then again you can see here there is a change in this one. There is a change. It is changing, see now, from low to high it is changing. It is changing from low to high, and it sustains into the high position until the next threshold takes place. Let it be whatever it may be. It can be positive threshold, or else it can be lower negative threshold. My positive threshold, I call it here as a upper threshold. My negative threshold, I call it as a lower threshold. Whatever may be the threshold, whenever your input voltage exceeds the positive threshold or lower threshold, there will be change in this signal. The output is going to switch from high to low or low to high. Then the sustaining of that output in that particular state will be until the next threshold crossing, until the input crosses the next threshold. You can see now here the change has taken place, and your input is still in that, your input is beyond that one. It is not crossing the next threshold. What is the next threshold? It's a lower threshold should come. So that's the lower threshold. Whenever it crosses the lower threshold, until that point you are having the value, the output is sustaining. See now, I'm getting the inverted outputs here. If I connect this one more thing now, since I have connected my input to the negative terminal, I'm getting the inverted output of this signal. If I connect this one, if both these two are interconnected, then what I'll be getting? If my input signal is connected to the positive terminal, I'll be getting the in phase one. That will be same. Since I have connected to the negative terminal, I'm getting this kind of operations. So this is regarding what happens in the Schmitt trigger. Schmitt trigger is what? Schmitt trigger is a circuit which is going, the input of the circuit will be triggering the output. Triggering the output means what? The output is going to change whenever the input is exceeding some particular levels of the voltage. That level of the voltage, if the level of the voltage is in the positive one, if it is a positive one, I call it as an upper threshold voltage. If the level of the voltage which you are calling exceeding point in the lower one, in the negative point, I call it as a lower threshold voltage. So now you can see here, now there is another circuit, R1 and R2. See now, this R1 and R2. What are these two resistors? These two resistors are acting as a voltage divider. R1 and R2 is acting as a voltage divider. What happens here is that where the voltage crosses, where the voltage across this R1, here you can see this R1 and R2 is called as a voltage divider. The voltage across this R1 is nothing else but this voltage across R1 is again fed back into this particular op amp which is acting as a Schmitt trigger. The voltage across this R1 is fed back into this one, and that particular into the positive terminal. And you can also see that the voltage across R1 is a variable voltage reference threshold voltage. This is a variable, right? It is a lower threshold voltage. So the voltage across this R1 is again one of the threshold voltage. Therefore, I can say that this value of this threshold voltage depends upon the value of the polarity of this output voltage. Why? Because this R1, how to calculate the voltage across R1? I need to apply again the same formula of voltage division method. If I apply the voltage division method, then definitely the V out also comes into picture. What is a V out? In the V out, there is a change in these polarities is happening. Sometimes the V out is positive and sometimes the V out is negative. So the voltage across this one R1, it is fed back into the positive terminal, and also the voltage across this R1, it is one of the threshold voltage which is variable. Why it is variable? Why? Because this threshold voltage or this voltage depends upon the polarity of your output voltage, polarity of this output voltage. So I can say now, whenever the V out is positive Vsat, whenever the V out is positive Vsat, what is happening? Whenever the V out is positive Vsat, the voltage across R1 is going to be the upper threshold voltage, this one. Is it okay? Is it clear now? Whenever the V out is positive Vsat, what is happening? If V out is positive Vsat, I can say that the voltage across R1 is what? VUT. Whenever the V out is equal to negative Vsat, I can say the voltage across this R1 is VLT. So that is how this switching takes place between the input and output. So this is regarding the Schmitt trigger, how the Schmitt trigger is going to work. Now let us enter into the calculation part. Whatever I explained, those things I'll try to calculate with the help of some concepts which are studied in the physics. So see now, as long as V in is less than VUT, as long as V in is less than VUT, your V out is going to be VSAT. So see now, as long as V in is less than VUT, as long V in is less than VUT, your output is going to be what now? Your output is going to be positive VSAT. You can see at this small instance, your V in is less than this VUT. It has not yet crossed this one. It is not yet crossed means what? Your output is going to be positive VSAT. So that's what we have written here. As long as V in is less than VUT, then V out is going to be positive VSAT. And how to calculate the this one VUT? We will be applying the voltage division method. We will be applying the voltage division method over here. That is, we are calculating the voltage across R1. So it will be R1 upon R1 plus R2. And what is that value over here? It is a positive VSAT, the output value. The output is going to be the positive VSAT. That's why I get my equation. The voltage will be positive VSAT. Then coming to the next one. For V in is greater than greater than VLT. Whenever the V in is greater than VLT, your output is going to be minus VSAT. You can see now. Whenever the V in is greater than this one, you can see now. Whenever the V in is greater than VSAT from here to here, if it enters into this one, it becomes lower than this one. So from this point, from 0 point to this VLT, whenever the V in is greater than VLT, your output will be always in terms of minus VSAT. Once if it crosses this one, or once the V in exceeds this one, again there will be change. Again it goes to what? Positive VSAT. Again it goes to positive VSAT. So now that's why whenever the V in is greater than VLT, your V out is at minus VSAT, and apply the same formula of voltage division method. But here the voltage is what? Now the output is what? It is a minus VSAT at this point. That is the voltage across R1. So that's why it is the voltage division method. If I apply here, it becomes R1 upon R1 plus R2 into this output voltage. What is the output voltage for this case? Your output voltage is whenever the V in is greater than VLT, output voltage is in the minus VSAT. So that's why it is minus VSAT. Now you can see what is a hysteresis. Hysteresis is nothing else but hysteresis is a voltage which is existing between the VUT and VLT. VUT and VLT. Between this VUT and VLT, we can see between these two voltage limits. That is called as a hysteresis voltage. That is VUT minus VLT is a hysteresis voltage. If you substitute these two formulae in this equation, you will get the hysteresis voltage. So this is how you find out the same explanation what I have given here. The same thing is been notated in the form of this arrow mark. The same thing is been notated in the form of arrow mark. You can analyze this one and you will find it out that how it has come. So now this is regarding what is meant by Schmitt trigger. In the Schmitt trigger, what happens whenever your input voltage crosses which point? Whenever your input voltage crosses some voltage level, then only there will be change in the output. That change in the output only we call it as a positive VSAT or negative VSAT. What voltage it has to cross? It has to cross some voltage in the positive. That is that voltage which we have named it as what? Upper threshold voltage, and in the negative we have named it as lower threshold voltage. So in the Schmitt trigger is nothing else but it's regarding about how your input triggers the output. Input, that's why it's called as Schmitt triggering. Schmitt triggering means what? It is triggering the output. Your input is changing the output. So that's why we call it as a Schmitt trigger.